You're going to give me the code? Is there a code? All right. Hello, everyone. Welcome to Code Chrysalis. This is Big MiniConf. We have 18 tech talks for you today. Track A is right here. Track B will happen in the room in the back, so feel free to roam around, find the talks that interest you. And so the talks we have for you today are part of the immersive curriculum. And for 8 weeks, these engineers have been working on these talks, at the same time building advanced software engineering projects, building their communication skills, and challenging themselves every day. So I just want to give a hand in recognition of their effort. Without further ado, let me introduce you Travis Ricks, who will talk about service workers.
Okay, thanks, Vic. Good afternoon, everyone. This talk I'm going to talk about what service workers are, how you can use them in your websites or web applications, and how to create a basic one. But before I do that, I'll talk about myself a little bit. So I've been in Tokyo for a year and a half now. Before moving to Tokyo, I lived in Michigan in the United States, and I worked mainly as a product manager at a small startup. We built content management systems and websites for student media organizations. And so I was the product manager and also did front-end design and client relations. And I'm currently looking for front-end opportunities here in Tokyo. Okay, so let's talk about service workers. But before we can talk about that, we need to talk about the main technology that is used by service workers. And that is progressive web apps. Has anyone heard of those before? Okay, cool. So what's a progressive web app? So progressive web app is a website or a web app that feels like a native app, an iOS app, but it doesn't have to be installed. It's just served through the browser. Users can save it to their phone, like save to home screen, but they don't have to install it through an app store. And one of the reasons that's good is that it's easier for the user to start interacting with it. They don't have to download it. They can search for your site and find it through Google search and start using your app-like experience right away. And the features that it has are offline functionality and push notifications. So we all live in Tokyo. I'm sure we all ride the trains and have gone through a tunnel and stopped having internet connection, and it's kind of frustrating. So one of the things that progressive web apps are good at is that they make the experience seamless by having support for what to do when the browser can't connect to the internet. And a good point for developers is that you only have to maintain one code base. You don't have to have a code base for your iOS app and a code base for your Android app and then a code base for the web. Everything can just be done in one code base. So it makes it a lot easier to maintain for a developer. So some popular ones are Twitter has a really popular progressive web app. Of course they still have, a native iOS app and native Android, but if you just access Twitter through the browser, you can get a lot of app-like features. Airbnb also has one, and The Guardian, which is a newspaper in the UK, also has a popular web app, progressive web app. And so how do progressive web apps do these things? Offline features and push notifications? Well, they use service workers. Okay, so what is a service worker? So basically, a service worker acts as a proxy between your application and either the user's local cache or the network. And it's just a simple JavaScript file, but because of the APIs that exist for it, it has a lot of power. So it's considered a web worker. And what that means is that it actually operates outside of the main thread of the browser. So even if the web page isn't open, the service worker still works, can still receive network requests and still do actions. So what can service workers do? So a big thing that they can do is cache assets locally. And so this can improve page performance because the websites don't have to continuously get assets from the network. But it can also enable offline functionality because let's say all of your assets are linked on the web. If the internet connection is lost and user goes to another page or reloads their page, none of those assets are available. And you can also enable sending push notifications. So you can do that on the browser, like it'll pop up in the corner, or on an app pop up on the home screen, which really helps with user engagement for your brand. So how do service workers do this? So basically, the way a service worker works is if you have a service worker in your code base, the first time a user goes to your website, the browser registers the service worker. And I'll show you all of this in code in just a minute. And then once the service worker is registered, it begins listening for events. So different things that you specify in your code. So like a button click or a network request or that kind of thing. And yeah, and also it can intercept network requests, which I mentioned before about choosing to load assets from the cache versus to load them from the network. And if your service worker is updated, the browser will update it. But one catch about this is if a user has like your page open and you send out a new service worker, the service worker won't actually be updated until they close all of the tabs of your site. And I'll show you this in the demo. So it's just something to keep in mind. If you're adding features to your service worker, you want to make sure that they're enhancements and not like a critical feature that if the user can't access it, will break the app. So you want to make sure it's just an enhancement. Okay, and a good thing, can I use service workers? The answer is yes. So this is from Can I Use? And so right now, this is from a few days ago. It's supported in over 93% of browsers currently. So all of the major browsers, Firefox and Edge and Chrome and Safari, and also the mobile browsers all have support for it. So you can confidently add it into your projects and know that most users will be able to use these features. Here's some tools for building service workers. So in Chrome, in the DevTools, there is actually an Applications tab, which I'll show you today. But it shows you the service workers, shows you all the service workers on your site, and lets you have some tools for developing them. Oh yeah, forgot to add this. Yeah, so we'll see this during the demo, but so this is the tab, and you have some features here. It shows you when the service worker was registered. Here, you can remove it from the site if you're doing testing. You can test sending push notifications and syncing. And you can also simulate offline experience really easily. So, something fun you might want to do sometime too is you can see all the service workers that are registered on your browser from all websites. So if you ever want to see who all has stuff going in your browser, you can check that out sometime. So in addition to Chrome DevTools, Google Workbox has a lot of tools. It's specifically for progressive web apps, but since service workers play such a big role in progressive web apps, there's a lot of service worker specific tools that are part of Google Webbox. And then also for those of you that use Node and Node packages, Generate Service Worker is a good one to add. And all of these links are in my GitHub repo, which I'll have a link of at the end of the talk. So if you want to check these out. And for those of you that use Create React App, you might have noticed when you do the basic installation, it actually comes with a service worker already included. Okay, so let's see our first service worker notification. So I'm going to do a push notification demo. Okay, so here's our website, and we just got a button here to trigger our push notification. So I click the button, and you can see there it is in the corner. So it just says where it came from this website, the URL, and the message. You can make these more feature-rich. You could include URLs or photos if you wanted to. This is just a basic one. Oh, whoops. Okay. And I want to show you, if we make some changes, how those changes get sent to the service worker. So, can everyone see this tab okay? So this is Chrome DevTools, and then I'm on the Application tab, which you can get to from this drop-down. So you can see I've got a service worker running now, and what time it was running. And like I said before, you can, if you have some time, you can scroll down here and see all of the different sites. Ooh, lots of service workers. Okay, sorry. The first time I looked at that, I was kind of surprised how many sites actually are using service workers. I thought, okay, that's good to know. But let's make a change to our push notification and see how that works. So I'm just going to go into the code. Okay. So let's just try to change the body of the message. So we'll just say, Welcome to CC. So I'm gonna save this and go back to the demo. And you can see now if I reload the page, over here on the right in status, there's a new service worker waiting to be installed. So let's see what happens if I trigger the push notification. Okay, but so this is what I was talking about before. If the user has any page open on your site, the service worker won't be updated until all the pages are closed. So one of the ways you can get around that when you're developing is to use this checkbox, update on reload. So that's really, I pretty much just have that checked all the time when I was working on these. So then that way, anytime I refresh the page, the service worker updates over here, and when I, try to test, I can get what I'm trying to get. So that's a good tip, is to use the update on reload button. Okay. In the GitHub repo as well, all of these code samples are there too, so you can have a look. Okay, so what are some challenges using service workers? So one challenge is that since we saw before that it's basically acts as a proxy, there's a lot of security vulnerabilities associated with that. So service workers can only be served on websites that use HTTPS. So if your site or web app isn't using HTTPS currently, it can't use service workers. So you have to change your site to be using secured. And also, like I said before, you want to make sure the features that you add to the service worker aren't like critical features to your app, because sometimes in some browsers, the service workers don't always work. So for instance, like right now in Mozilla private mode, it doesn't always let the service worker run. So it's just something to keep in mind that there are some quirks between different browsers when you're using private mode or incognito as to how it handles support for the service worker. Okay, let's look at how we can build our first service worker. So like we said before, the first thing that happens is that you have to register the service worker in the browser and verify that the browser supports service workers. So a simple code sample for that could look like this. So this is just a simple JavaScript file, and it's checking in the navigator object to see if service workers are supported. And so if they're supported, it registers it, and it's just a simple one that's at the root directory of our project, and if not, it fails. So this code or variation of something like this has to be in your main JavaScript, not in your service worker file. You put this in your main.js or your app.js, and that's what will install the service worker into the browser. And so what does an actual service worker file look like? So once it's registered and the browser, you verify the browser supports it, it's now installed and activated and listening for events. So here's like a sample of what your service worker file could look like. So this would be if you were caching assets locally. So when you're installing, you specify all of the different directories that you want cached locally, and now the service worker will use those instead of the network if, for instance, you go offline or you're using it just to serve cached assets to make your site load more quickly. Okay, so now I'm going to show you what an offline fallback could look like. Okay, so here's just like a standard page, and it's not using a service worker. And we can verify that by going into the DevTools, and you can see there's no service worker for this site. So typically when you go offline, you know what happens. You lose the whole site, you lose the app, and the user's taken out of your experience. You get the angry T-Rex or whatever the browser has decided you get. But if you're a brand, you don't want that to happen. You want, even if the network connection is lost, you still want to keep the user inside of your app and in your experience. And so we can do that with Service Worker. So I'm just going to launch. This is the same page, but this has a Service Worker installed. And so yeah, we can see it's activated and it's running. And so now I'm going to go offline and refresh the page. And I got a landing page. So yeah, I'm offline, which is sad, but I'm still in the brand. So this is a simple example, but this page could have, it could be the whole page the user was on. It could be page with like things to do while you're offline, or maybe you want to help them troubleshoot their internet connection. I mean, it's really whatever you want, but the important part is that the users, even though they don't have an internet connection, they're still able to use their app and use your website. Okay, too fast. Yeah, so basically the things I want you to remember from this talk is that service workers add native-like features to your website or to your web app. That you must serve your site or app through HTTPS for them to work. And you can feel safe to use them because they're supported by over 90% of browsers. And that's it. Thank you for coming. If you want to see this slide presentation or some code samples or resources, the QR code goes to my GitHub page that has all of that information. And thanks for coming.
Thank you very much, Travis. That was great. Let's take a small break, and we will be back with Kota Aoyama talking about search engine creation at 1:30 here again. Thank you.
like a grep command in Unix. So simply search the one by one. Yes. So let me show you example of sequential. This. So now I'm searching the word love in this document. So actually, this document is my talk script in previous slide. So the first history of Elasticsearch could be their love story. So like this. So check the one word and to next word. Yeah, simply, right? So yeah, check. Not it love. Not it love. Yes. Oh my god! I finally found the love. Yes. So yeah, sequential is like that. But yeah, as you guess, the sequential has a problem. So if the volume of document is very large, the operation doesn't end during the practical time. So there is a second one, index. So actually, almost all search engine use this type, and Elasticsearch also. So in this way, so in advance, indexes are created, and searching the indexes are used, and the concept of inverted index is usually used. So next, I'll explain what's inverted index. Okay. So this is an example of inverted index. Yeah, there are two documents. First one is who is this masculine man? And second one is he is my host father. Yes. So firstly, yeah, simply so sentence is divided into words like this. And document 2 also divided. And yeah, so English has a spelling inconsistency. So capital case merged into the lowercase like this. So also he is lowercase. And then so this is the inverted index table. Inverted index is a combination between the words and the documents that contains the word. So in this case, there are 9 indexes. So only is exists in the both documents. So is 1, 2. The other one is only in the only one document. So father to he 2 or something. This is the inverted index concept. Yeah. So next one is the structure of full-text search engines. So there are main 3 parts: crawler, indexer, and searcher. Crawler is regularly crawling the internet or local document. So search target and update index. And indexer creates an index database like this. And searcher offers a search query on basis of the index. The indexer created. And yeah, when user want to search something, use searcher and gets data. Yes. And next is different from relational database. Yes, relational database is a traditional database. So it's same thing as storing data. So both full-text search engine and relational database is storing data. But it's different is so full-text search engine use scoring and arrange and compare the search result while relational database get all data fits a match search condition. Okay, so from now I'm talking about Elasticsearch itself. So firstly, scalability. So when you insert data into Elasticsearch, the data is invited into several units called shard. So this concept, distributed, is used in the other databases as well. So it's a common concept. So, Elasticsearch also uses this concept. Okay, so thanks to that, more and more data could be stored into the database without decreasing the search quality. And next is RESTful API. So as I said, Apache thing is written in Java, so user have to write a Java API. But in Elasticsearch, you can do everything via RESTful API. And also, so access via client library is allowed. So actually, I used a Node.js client library and creating a search engine. So I'll show you in the demo time. Okay. And next one is document oriented. This is important, I think. So Elasticsearch is a document oriented database. So search query or search target or search result is all represented in JSON format. That means you don't have to define the schema before inserting data. So while relational database, you have to do, right? And exactly, so you can save the business logic as a exactly correct data structure. So while relational database, so usually when you insert create the schema, the schema already exists. So you have you sometimes you usually have to change the business logic. That means that so divide the table. Yeah. So so you have to change the business logic. But so it's important, useful, I think. So yeah, and fourth one is visualization. Actually, Elasticsearch can connect the other softwares such as logging or visualize. This is an example of the e-commerce revenue data is inserted and showing the data. For example, first one is sold product by day and sold by gender and average sales price and average sales quantity and total revenue and sales by category and promotion tracking. And this is sales by country and top selling product and orders log. And you can this is you can check whether part of clothes is sold like that. So next one is a logical concept of Elasticsearch. So you can grasp the logical concept of Elasticsearch with the analogy of a kind of analogy with relational database. So index is just like a database in relational database, and document type is just like table. And but actually, so now Elasticsearch is moving towards eliminating this document type concept. But latest version still has this concept, so I keep it. And document is just like row or record in relational database, and field is just like color. And this is example. JSON format, right? And this is an example of field. So key value pair and like column, also field has a data type. And physical concept of Elasticsearch. So there are several servers called Node, and where Elasticsearch works. And you can consider the Node is a Java virtual machine instance. So because Elasticsearch works on the Java virtual machine, and Node communicate with each other, and the group of node is called cluster, and data is divided into a shard, and shard automatically copies replica. So like that, yes. So finally, I'll show a demo. But before that, I'll explain the dataset. So this in this demo, so I used the recipe document files. So this is recipe JSON files, and I put these files in local. And every document has this field, recipe field. And this is a tech used. Actually, I don't use crawler because the data, I put data in the server. So, and indexer and searcher is Elasticsearch. So, and I use the Node.js client library, and I put the data in the server, and front end is React. So I'll show demo. This is a demo. So recipe search. So for example, I'll type the vegetarian like that, and type the enter. So some document are hit. And for example, so check the second one. So sorry. So just showing the raw data as a table format. But so I'll check whether this document exactly contains the keyword. So yeah, vegetarian. So what in this demo I want to show is I insert the data as a JSON document, and I get the data by a keyword. So yes, like that. Okay, so yeah, it's simple, right? So yeah, actually, so if you might create a search engine for your partner, so the relationship might get better, I think. So just like Shaibano. So thank you for listening. So if you are interested in this topic, this QR code is my repository. So please check. Thank you for listening.
Thank you, Petra. That was really interesting. We will be back at 2 o'clock to see Haruna Utsumi talk a deep dive into the browser. Thank you. All right, next up is Haruna Utsumi, who will talk about deep dive into the browser internal processing. So give it up for Haruna.
Hi everyone, today I will talk about deep dive in browser internal processing. First, let me introduce myself. I'm Haruna. I was born and grew up in Chiba. I was working as a project manager under the UI team. After that, I worked on launching a new service in the same company. During that time, I felt I want to increase my knowledge and talk more deeply with the engineers. And I challenged POC, proof of concept creation activity, and I found writing code was fun. So I want to be a software engineer, and I'm here now. Now, I will tell you the background of this presentation. My previous company developed car navigation system. The developers always had hard time solving performance issues such as long loading time, loading screen, and slow scroll on the map. If we tried hard after the release, we got feedback for performance. So then I'm interested in performance optimization. What do you think about these three numbers? The researchers said there are three main time limits to keep in mind when optimizing web and application performance. These are numbers the time. Performance is really important. At 0.1 seconds, users will not notice delay. Users will be happy. After 1 second of loading time, users may start to notice a delay. 10 seconds is the limit for most users to wait for loading page. After 10 seconds, most users will leave at the page. Speeding up page load time can increase conversion and engagement. So performance is really important. And there are many tips for performance optimization on the internet. For example, minifying resources for CSS, putting the style sheets at the top of the HTML, and avoiding to use import, also avoiding deep nesting. For JavaScript, using async or putting script at the bottom on the HTML, removing duplicate scripts, and making JavaScript asynchronous. There are many others. If you don't understand what's happening in the browser and use as a black box, you need to memorize all the tips and just follow them. This is inflexible, and every time you come across a new framework, you have to memorize them. However, if you understand the browser deeply and why these deep tips improve performance, you can apply your knowledge to other frameworks. Also, if we can understand how the browser processes our code, writing code will be more fun, I feel. So first, I will tell you what happened between the time browser opens the site and browser displays the content. Chrome has developer tools. I put the screenshot of the performance tab of the Chrome developer tools in the right side. We can know what kind of processing was done and how long it took. If you understand the browser's internal processing, you can analyze the website performance with this tool. There are 3 points to speed up website: network processing, rendering processing, and script processing. Network processing is to download HTML, CSS, JavaScript, and image from the server. Rendering processing is to display elements on the basis of HTML and CSS. Script processing is to execute JavaScript. If resources are small, network processing finished fast, the browser goes next step. Let me show you rendering processing because it's complex a little bit. This is a rendering process flow where user requests a website and the browser displays it. When first load this page, the browser processes all these steps. When later contents are updated, the browser only processes necessary steps and skips unnecessary recalculation. I will look at each step separately. In the first step, browser analyzes HTML to create DOM tree, and analyze CSS to create style rules. DOM tree is to define HTML tag structure, like this. The top of the DOM tree is the document. Style rules maintain selector and declaration as a tree structure. Next, I will explain the style step. In this step, the browser connects DOM tree and style rules. Specifically, it evaluates which style is applied to which element. If multiple styles are applicable, it determines style based on priority. Browser does style step when the browser first loads the website. If JavaScript updates DOM or CSS properties, the browser does this step again. Let me show you how JavaScript triggers style step reprocessing. In this example, the JavaScript updates element color after some delay. The image on the right side is the output of the Chrome developer tools performance analysis. And after JavaScript exclusion, the browser does style step again. Next, the browser calculates position and size of element using the render tree. This step is called layout or reflow. Since the browser will walk through all nodes in the tree, if the nest is deep, this step will take a time. As a result, the browser determines the position of each element. The browser knows the position, size and color of element at this point. Similar to style step, browser does layout step when the browser first loads the website. If JavaScript changes the position and size, the browser does this step again. Next, I will explain the paint step. This step creates paint records. Paint records have instruction for the actual drawing order. This order is decided by layers. This is the last step. This is called the display step. First, a bitmap conversion is performed. This is called the rasterization processing. When the processing of each layer is completed, they are aggregated and displayed and sent to the GPU, then displayed on the screen. Finally, the rendering processing is over. Next, I will introduce how the browser does rendering processing with multiple threads. The web browser has main, raster, compositor thread. The main thread is responsible from path step to page step. Also, the main thread performs script processing. So the main thread is always busy. Therefore, it's important to reduce the load on the main thread. As I mentioned before, if JavaScript upload element properties, the main thread needs to reprocess some steps. The transform and opacity of CSS properties, which are often used for animation, is performed in the display step. Since these don't involve the main thread, they are actually lighter than changing layout properties. We can see them on developer tools. Let me explain one of the performance optimization chips from the internal processing perspective using demo. I use this chip as an example. Using the async attribute arrows, rendering processing without waiting for script download. One thing we should be careful about is that if we use async, the browser does not guarantee the order of JavaScript execution. So one of the use case of the async is independent third-party scripts. I will show you a demo. I created the website which downloads JavaScript. This JavaScript just updates the text string and the color on the website. To make the effect of async query, I increased the download time of this JavaScript by adding some delay. The normal website has a script tag without async property. So rendering processing is blocked by JavaScript download. And we cannot see any content until the browser finishes download the script. Improvement website has a script tag with async properties. So rendering processing is not blocked by JavaScript download. Look at the hello world. You can see the install screen. The text string is changed. After browser download and execute the script, rendering processing runs again only necessary steps, and the screen is updated. You can see using the async property here. For For this normal website, browser processing looks like this flow. When browsers pass the script tags, the browser does not finish downloading the JavaScript yet. So the browser waits for JavaScript download. After finish download, execute JavaScript, and then resume rendering processing. For this improved web page, browser processing looks like this flow. When browser passes script tags, the browser does not finish downloading this JavaScript yet. However, we used async properties on this website. So the browser does not wait for JavaScript download, finish rendering processing. After finish download, execute JavaScript, and then does rendering processing again. As a result, the browser can display the initial screen once before JavaScript was executed. Now, we know what's happening in the browser. Let me show you some of chips again. Minifying resources can finish network processing faster. Putting CSS at the top of the HTML makes rendering processing start earlier. If CSS has deep nesting, it takes a long time to create render trees at the layout step. Usually, we don't need to care about the browser processing, but knowing this is helpful. Let me summarize this presentation. First, I talked about 3 points that have a large impact on website performance: network processing, rendering processing, and script processing. Second, I described the detailed flow on the rendering processing. And last, I explained how multiple threads execute rendering processing. And I show through a demo, it will help you create better performance website. Now, we can analyze web performance really flexible, rather than just memorizing the chips and following them. If you feel your service is slow, let's analyze the performance and make your service faster. If you would like to know more, please visit my GitHub. Thank you for listening.
Good job, Aruna.
Thank you.
We'll be back at 2:30, where Rafael da Silva Viana, right? That's not Rafael, sorry. Rafael is over there. He's gonna come and talk about building a software engineering product. So, thank you. All right, let's welcome Rafael da Silva Viana, talking about building a software engineering product together.
Thank you, Vic. Good afternoon, everybody. My name is Rafael Viana, and once upon a time, I built a software product to solve a problem of my community. And now I'm doing the same thing all over again. Before joining Code Chrysalis, I worked as a tech support / interpreter for Entity Docomo. I did T1 and T2 and interpretation in both Portuguese and English. And before that, I had a food truck business with a friend of mine. This friend of mine worked hiring golf caddies to a Japanese golf course, mostly South Americans. And the golf course was in a very remote area. The clubhouse had a restaurant for members, but there was nothing for employees. So their only option was to bring their own food. We started a Brazilian-style chicken food truck and sold lunch boxes at the parking lot of the golf course. This is us. That's pretty much the same thing we'll be doing today with software. We will identify a problem and we'll build something to solve the problem. But why software? I mean, why not? It's super easy to get started. You don't need a roast chicken machine, no industrial kitchen apparatus. If you know how to code, you basically just need a computer. And that's it. Much lower entry barrier than, well, any industry. And it's also super scalable. So the companies that go from 0 customer to millions of customers is not a thing that even happens in other industries. So why wouldn't you have a software product if you're trying to solve a problem? Pretty much for the same reasons. If you're competing, if it's super easy to get started and if it's very scalable, that means that you're competing with people from everywhere that can sell their products anywhere to anyone. So the competition is crazy, and that's precisely because the entry barrier is so low. I'll be focusing on web apps today, and they got so much better than they used to be. Imagine that you are building like a search engine for a web browser or a video streaming service. You'll be competing with some very heavy players. So how do you compete with them? You don't, not with those guys. It's like the aviation industry. At the beginning, people broke into the industry by putting together machines in their garage. But as aircrafts raised in complexity, it became infeasible for an individual to single-handedly enter the industry. There's always outliers though. But there are a bunch of problems that haven't been addressed yet. And to solve them, you must have only 2 things, according to me. A deep knowledge of the problem and passion, and lots of passion. Because if you don't, you probably won't get through the painful process of building a product. So, an example of a problem. When I went to work for Docomo, actually before I went to work for Docomo, I felt I was ready for the job. I knew my stuff, but I wasn't ready for the job interview itself. It was a painful process, and like interviewing and writing a resume in Japanese, it's a very cultural heavy endeavor and full with idiosyncrasies that I was not anticipating. And I feel that a lot of people I know, a lot of skilled people that I know, work in different fields in Japan precisely because the recruiting process is something that they cannot comprehend. So that's a problem I had, That's a problem that I know a lot of people have. That's a problem I deeply care about, and that's a problem I'll solve with software. My software product will be a resume builder for Brazilians living in Japan. How do we do that? Step 1, validate your idea. So Airbnb at the very beginning is a great example. Founders couldn't afford their San Francisco rent, and they recognized that due to a big design conference, people couldn't book accommodations. So they hacked a website in a weekend. They put some mattress in their living room, and they've got free customers. If you can do that without writing code, even better. The next step, which was not the way I did it, but if I were to do it again, that's absolutely how I would do it. You must have a clickable prototype. So just something that gives the user the feeling of what the product is about and how it works. There's a great tool for that. It's called Keynotopia. You can just upload Keynote and not Google Slides, Microsoft PowerPoint, and create simple, clickable user interfaces. I did a full stack app, kind of, because I had to for Code Chrysalis. So it was the very first step of the resume builder, and my idea was you wrote your resume and you saved your changes. And the best thing that I've learned from this is that the best thing that came out from this is that I had to deploy it. So I had the opportunity to show this to some people I knew, and the consensus was people hated. No one liked my resume thing. First, because it was not well built, but secondly, because the idea of writing something and saving to a database so that afterwards you could handwrite your resume, which was how I did it. I spent like many sheets of paper writing my resume, then I handwritten my resume and took to Docomo. There was not something that people wanted to do. They just wanted something that they could print and quickly take somewhere. So my idea was wrong from the very beginning, and the ability that I had to show that to people and get that, why would I do that, was very important to everything that I did afterwards. So if you can take one thing from this, validate your idea before you do anything else. Step 2, build incrementally. So after you validate your idea, build a product as fast as you can and get it to users and get the feedback from them. In my food truck, I had one lunch box for people that wanted to eat at their lunch times, for workers that wanted to eat at the lunchtime at the golf course. But some people wanted a snack kind of thing, and some people asked for chicken, broccoli, potato, but no rice. So we heard the feedback and we iterated and built upon that. Some people wanted a whole chicken to take home for the families because they were tired after work. So we did that as well. The point is, this is the same thing that you have to do with software. You find a problem, like for example, building a resume in Japanese, and you find people that want to do that, and you assume that you need a login system because they want to fine-tune whatever they wrote, but they don't. So check first, iterate quickly, and build upon it. So after I've heard from people that I showed the resume thing, the next step was building what they actually want, which was a simple resume. It's just front end. You can check for the inputs and outputs on the resume templates. But they wanted to download or just print the resume. So that was the next thing I did. I implemented 3 buttons: a download button, a print button, and an upload button. The upload is just for photos. And the other thing that's in Portuguese, but there's an explanation of how people can fill out various areas, and also a vocabulary section for how to use some common Japanese words in the resume. The thing here is, well, deliver quickly. Don't give yourself too much time, because that's the great thing that I have received from Code Chrysalis, because I have to build something quick in 3 days, and I'm a slow learner, and I'm procrastinator by default. But if you have a feature that would take more than 3 months, don't do that. Like, break it down into a smaller chunk, solve that problem, give it to your customers or people that would use your software, hear what they have to say, and then build more. Next step, experiment with price. After you have got yourself some users, there's things like business plan and initial pricing strategy. Those are wonderful concepts. I don't see them working in software. The reason is software is a weird business. It's so strange. If you plan to have a sustainable business that grows and you have billions of customers, it might make sense to give your service for free or close to free. But if for the same product you have hundreds of customers, it might make sense to charge thousands of dollars, and both approaches are okay with software. For instance, Urchin is a company that did web analytics. They had several services, but the most basic was $400 a month. Google bought them. They renamed them Google Analytics, and now they offer it for free. I'm a strong believer in free software in both senses. At least initially. My idea with the resume thing is to make freemium. If you want to use the software to build a resume, you can just do that for free. But ideally, you'd have more options. To be honest, if a single person uses my app and they take what they use and they can actually use in a real interview, I'm happy with that. But I feel I can offer more. So for example, I could include services such as a resume review service or a video interview prep. You don't have to use it, but it will be an optional paid service within the platform. That kind of thing. There are roughly 300,000 Brazilians living in Japan. That is my market for this app. And it's a small market. But so is, let's say, a college campus. As I said, if one person uses my product, I would be thrilled. That was something that I built to check how good I learned the skills that I was learning in my time here. But Japan has a shortage of workers, and there's a problem that needs to be addressed for the economy to be a healthy economy. And that's not unique to Japan. This might be my college campus. But honestly, at this point, that doesn't even matter, because this is a problem I care about. I'll give my everything to try to improve the quality of life of my countrymen. And I don't know if I can solve this problem, but I'll try. And I look for more problems I care about, and I think you should too. Find a problem you care about, find a dozen. Give your everything to it. Solve more problems, solve harder problems. Solve problems that will make life better for someone. Solve problems that will make a positive impact within a community. Let's build a product that hopefully sells a lot, but ultimately can connect us as human beings. Thank you very much.
Good job, Rafael.
Gracias.
Next up will be Sachi Granan, talking about how do computers know what we like, recommendation systems. Let's be back here at 3 o'clock. All right, next up is Sachi Granan talking about how computers know what we like. An intro to recommendation systems. So, give a hand to Sachi.
Hello everybody, how are you today? Good. It's nice weather. Today I'm pretty excited about talking about how a computer knows what I like. This will be introduction to a recommendation system. Before I get into the main topic, let me introduce myself a little bit. My name is Sachi Granan. I am from Yokohama, Japan. But last 3.5 years, I live in beautiful beach city called Sunshine Coast in Australia. I'm here to just attend this course. I was a hairdresser over 12 years, both in Japan and Australia, solving problem related to hair. But I love traveling, especially in small island, and I love scuba diving and skin diving. So skin diving is probably not a very common word. It's just hold your breath, dive into the water. I can go maximum about 20 meters with a single breath. So that's a pretty calming experience. It's pretty nice. Okay, let's get into the main topic. That's a recommendation system. Do you know the recommendation system? Yeah. It's a system, the platform, to predict users' interest and recommend products based on their preference. So we use this system everywhere online, either knowingly or not knowingly. So for example, Amazon is one of the big companies that start using this system to recommend products to the user. Say if you're going on a holiday and looking for buying GoPro. So this page usually shows recommendation at the bottom that suggests similar products. It usually they're very similar, like GoPros, different color or different models, or even the same products from different company, could be cheaper. So this is very helpful to choose what you actually want to buy. And once you decide which one to buy, another suggestion is right above. So in this case, it recommends you to buy SD card and head strap together. This is a great suggestion. Like, you don't want to go on a holiday with the brand new GoPro, but no SD card. You can't take any photo. That's a disaster. So you probably want to take this recommendation. Another example is SNS. You might be familiar with this. This is my phone on Facebook. It recommends a friend to connect with me if you have mutual friends. So nowadays, a lot of internet servers use this system to recommend either connect to friends or products. Spotify, for example, they recommend music based on your preference. And Netflix, YouTube also use these algorithms. This is the Netflix prize, if you know or not know. It was 2009. They offered 1 million prize if you could improve their recommendation system by 10%. It's only 10%. But it actually represents a substantial amount of business. It's hard to estimate how much it brings to Netflix, but for example, Amazon, 35% of sales they made is through this recommendation system. And their annual revenue is over $280 billion. So you can imagine how big the market is and how big this recommendation impact to the companies. Nowadays, 75% of what they watch on Netflix is come through this recommendation system, which is pretty big numbers. But why do we need recommendation? You know, we have Google, We can search whatever we want to buy, or we probably know what we want to watch, or even listen. But there are too many options. So thanks to the advancement of internet, I have a lot of choices. It's one click away. Spotify offers 10,000 songs. Netflix currently has 5,500 movies and TV shows that you can watch with just one click. And Amazon has 606 million items listed at the moment. It's just too hard to find whatever you want to buy or watch. So this recommendation system is a little helper for users to make it easy to find what they want. And sometimes surprise them with something you never searched for. Now, how does a recommendation system work? There's two major algorithms that are used. One is content-based system. This find items that is similar to what you have bought before or you have watched before. The other one is called collaborative filtering system. So it first finds similar user to you and recommend products based on the what similar users like. Let's see some example. Here's Nancy. She watched Finding Nemo last week and she really liked it. So she's just looking for another movie for this weekend. Back a decade ago, we probably go to video rental shop to rental a video. In that case, she probably go to the section where the Finding Nemo is, because this shop usually categorized all the movies by similarity or the genre. And she probably find Finding Dory or other Pixar movies like Minions or Monsters Inc. Because she liked Finding Nemo, most likely she enjoyed those movies. And the other way to get suggestion is from friends. Most of the time, that's the best way to find something really interesting. So she has a friend called John. And he also liked Finding Nemo. So she asked him for some suggestion what she should watch for this weekend. And he probably suggests some of the movies, like Star Wars, Adventures, or Frozen. But because she knows John has similar preference, she most likely enjoy his recommendation. So this is the basic idea of collaborative filtering. But sometimes those strategy doesn't work well. Because what if John likes completely different genre, like horror movie, and you ask him some suggestion, and he suggests you to watch something you're not interested in. So it's really important to find similar products or similar people to generate accurate recommendation. Now, how can we do that then? Let's have a close look at first content-based recommendation system. Okay, as an example, I picked Ghibli movies. 4 Ghibli movies I picked. One is Spirited Away, it's a pretty popular one, and Whisper of the Heart, Kiki's Delivery Service, and Castle in the Sky. So let's create recommendation to someone who really enjoyed Spirited Away. So which movies among these 4 that person will most likely enjoy watching next. First, we can generate a list of features about those different movies. For example, first I could consider which of those movies are directed by Hayao or Miyazaki, one of the famous directors. And you can create the table. Spirited Away, director is Hayao Miyazaki, but Whisper of the Heart, that was directed by Yoshifumi Kondo. And Kiki's Delivery Service, Castle in the Sky, are both Hayao's movie. And after that, I can add more features to this table by adding some rows into the structure. I could add some genre, whether they are fantasy movie or not. Spirited Away is fantasy, but Whisper of the Heart is not. And Kiki's Delivery Service and Castle in the Sky are not. Were fantasy movie. So I can add a lot of different features. Either they are actions, or if there is any romance involved. But I added some directors and genres, but those features can be anything about movies. So whether that movie won Oscar, or if there is any villain, or it could be how much those movies made at the box office. All those informations are very important to others. After creating those tables, we're going to look 2 movies into this table to see how similar they are. In this case, we want to find a similar movie to Spirited Away. So we start comparing with the Spirited Away to Whisper of the Heart. And to compare it, so to seeing how many their features are matching, and we can count up the score. So with them, Spirited Away is Hayao's movie, but Whisper of the Heart is not. One is fantasy movies, one is not. But both are not action movies, it matches, so it gets score 1 here. And one is romance, but one is not. So Whisper of the Heart received score 1. And you keep doing it with all other movies. With the Kiki's Delivery Service, which looks pretty much the same, so it received score 4. With the Castle in the Sky, both are Hayao movies and fantasy movies, so it receives a score 2. After comparing all other movies, I could tell the most similar movies by looking at those scores. In this case, score 4 is the highest, which means Kiki's Delivery Service is the closest movie to Spirited Away. So content-based filtering is based on all the features about movies. So I can build this recommendation by knowing what the movie is like. So all the features that they have. Let me show you a little demo that I created. So this is the Ghibli movie recommendation. Does anyone have favorite Ghibli movies? Yeah. Yeah, you can hear. Kurenai no Buta, Poco Rosso, isn't it? There it is. I can find 15. Come here. Yeah, when you click it, internet is not connecting. Sorry. Oh, it's working? A little bit slow. Okay, so it displays the recommendation. This is Moving Castle. Howl's Moving Castle is the closest movie to Barbarossa. So this is based on content-based recommendation system that has all the features implemented and then compared to the one you picked and then other movies and then generate the recommendation. Okay, go back to this slide. Let's see other recommendation system, how collaborative filtering works. This is based on user and then user connection. So a same example as a content-based movies recommendation system. Say we need a user. So I can ask friends, Michelle, Nick, Tyson, and Corey, and then I can ask them if they like those movies or not. And then I can create the table like this. And so we can make prediction using those tables. And if I only watch Spirited Away, and then I'm looking for a recommendation, what should I watch next? So first we need to do is filter those lists to find what the similar people would be. In case I like to Spirited Away, but Nick didn't like Spirited Away, which he doesn't have similar preference with me. So I'm gonna get rid of him for this comparison. And I can look at what Michelle, Tyson, Corey liked to those 3 movies. And again, count up. So let's take a vote to each movie. West of the Heart, for example, only Corey liked it. So it receives 0.1. Kiki's Delivery Service, the same. Only Corey liked it, so it receives only 1. Castle in the Sky. Michelle and Corey liked Castle in the Sky, so it receives score 2. So if I have to make the recommendation for myself, I can compare those numbers. Which is highest score number 2 is Castle in the Sky. So Castle in the Sky is most likely I enjoy. So all the information I use to generate this recommendation was not about the movies, but about the preference from other users. It means you need to obtain a lot of user preference data first to generate those recommendations. So it's one of the drawbacks of using collaborative filtering. But once you collect all the data, you'll get better with this recommendation. So I created another recommendation system based on collaborative filtering, but because I need to use the data, I had to use 10,000 user rating data to create this recommendation system. So it has a little bit more movie selection, so you can choose from. Once you click whatever you want, you really liked, it generates recommendation for you. And you can add some other movies that you like, and then this recommendation will get more accurate. You can also add some movies, or if you change your preference, you can delete whatever you liked before. That's a little recommendation. Those 2 movies recommendation, I used the JavaScript, but those are 2 very good library to use. So very easy to use, One is called Good Enough Recommendation System. So this is for collaborative filtering. It just takes the object and then calculate everything for you to create recommendation. And the other is name suggest content-based recommender. It takes one object with all the features that you put and then compare it to others and then create recommendation. It's very useful and then very simple to use if you want to create something recommendation system. Now, at the moment, all the recommendation systems are based on users' history. Users need to search something first to create to receive recommendation system. You know, Amazon doesn't recommend you anything until you search something. So your action is first. This is a famous quote from Steve Jobs. Now, customers actually don't know what they want until they see it. So we as a developer, we need to show users what possible products they might be interested in before they actually realize they want to buy or they want to watch. So the user doesn't need to search anything. So in the future, with the advancement of AI, this will be possible. So AI analyzes users' preference based on your daily life, not just searching on Amazon. And create recommendation perfectly personalized for you. And you open your computer and all the recommendation is already there. And everything is what you want, but you never thought about buying it. So I'm sure it will happen in the near future. Thank you for listening.
Thank you, Sachi. Very interesting talk.
Thank you.
Next up will be Ashley with immersive experiences in speech integrated AR. So if you're interested in augmented reality, you want to be here for this talk. We'll see that at 3:30. Thank you. All right, to talk about immersive experience with speech integration and AR, let's give it up for Ashley.
Hello everyone, thank you so much for joining us today with the whole coronavirus outbreak. We're really happy that you're here. And yes, I'm very excited to talk to you about immersive experiences. But first, who am I? So my name is Ashley Kekona. I was born and raised in Hawaii. And around 18 years old, I decided it's time for me to experience seasons. So I went to the other side of the United States, to New Hampshire, and I studied economics and Chinese. And during my time at college, I was a part of a hip-hop dance group. I really like dancing, and I've always liked playing tennis. I play with my family and my friends at home. And in general, I love anything related to art. And a year and a half ago, I came to Tokyo to work in a startup company. This startup company I interned at while I was in college. And there, because it's a small team, I got a chance to be involved with all aspects of the business. And it was really fun. And in particular, one project that I worked on was a system project. So I had the opportunity to work with very talented software engineers, senior software engineers, and they're the ones who got me excited about coding. So that's why I'm here today. Our startup company was in the inbound business, inbound industry. I don't know if you're not familiar with it, it's part of the travel industry. And before I joined this company, I didn't know too much about travel. I wasn't crazy about traveling to places. And most of my experiences with travel was heavily influenced by my best friend in college, who visited almost every single country in the world. She could even tell you if there was a sign on the side of the road, or sometimes even if there was a parachute flying over the side of the ridge. And this is because she traveled in Google Maps. She was a very avid virtual traveler. And for some people, this is enough. But for other people, like me, there's something that is not enough. And there's a reason why we go from one place, let's not forget the peg man, to another place, and again to another place. And there's some kind of drive that we have, and this is that we want to experience things ourselves. It's not maybe a coincidence that my route of life kind of looks like a Japanese fan, and I'm currently in Japan. But some things are just meant to be. And this is something I learned being a part of the travel industry, is that millennials are paying much more for experiences. They're traveling, they want to meet the people, they want to, interact with the people there and see things for themselves. So even when people request guides, they don't want people to tell them something that they can look up themselves on the internet, because all the information is already available to them, and they don't have to go there to receive that. And the same kind of trends can be seen in the tech world. Before I move on, I just wanted to briefly share with you what the difference between virtual reality and augmented reality. VR stands for virtual reality, and a lot of times it's when we immerse ourselves into a completely digital world. So we're transported into a digital world. And a lot of times you will see people with headsets. Augmented reality, we take a part of the digital world and bring it into our own reality. So a lot of times you'll see something like a smartphone. And in virtual reality, you're not able to recognize yourself as yourself in this virtual world. So for example, here we have, that's the user's hand, but it's rendered as a different model or image. And augmented reality people, the most popular or maybe well-known augmented reality app today is Pokemon Go. So this is in the streets. You see the street that you see in front of you, but Pokemon also there. This is an interesting diagram that I found, and I based a lot of my ideas off of this. It maps out the changes of how we characterize different ages and time periods. So we start with the age of manufacturing, and I interpreted this as this is when we create products. Our products are efficiently created. Next, we transition to the age of distribution, And I took this as these products are now being delivered physically, maybe airplanes and ships. In the next stage, age of information, the technology of how to create these products are made accessible to everyone, or more easily accessible. In the age of the customer, we're reevaluating these products and kind of returning and refactoring. And I decided to look at advancements in extended reality along with this timeline. And virtual reality and augmented reality have actually been around maybe relatively recently, but from before. This is when, around the time virtual reality became like more popular concept, augmented reality, but we didn't really see huge advancements in these areas until around this time, 2010s, and that's when we're reevaluating our products. So the demand is changing, and there's a shift in what people want. And that's, of course, based off of in technology that was made available previously. Now, this is around the time when Pokemon Go and virtual reality headsets became very popular. And you may think that these technologies are hard to get started with and difficult to use, but I'm hoping that today you'll, if you can take away anything, it's that they're not as difficult as you think, and hopefully you'll be excited about it. So to show this, I have a small demo for AR. And does anybody have 1,000 yen? It's okay if you donate it to our snack bar. I have 1,000 yen that you can use. It may be better if you use this on your phone. This is the idea of augmented reality. And if you, because it's 3D and it has tracking, even if you turn it, it'll be able to render the images in the correct direction. Why dancing people? I don't know. And the reason why I chose 1,000 yen is because I thought maybe if you're in the line trying to decide whether or not to buy something, or you're just waiting, you can motivate yourself by just seeing people dancing on it. Less guilty of spending it. So these are the advancements in virtual reality and AR, but I thought there has to be other aspects that make an experience immersive. And of course, ideally, I thought it'd be really cool if you could build something where you could physically interact with the digital world, so you can perceive, touch, and sense. But that may be for a future, some kind of different technology. And I thought immediately what's realistic now, maybe another way we can interact with the digital world is by speech and sound. So that's why I decided. That's why I decided to look at speech recognition. And it's interesting to see that speech recognition also developed in a similar way to extended reality. So we see it became a thing around the same time. And within this relatively short amount of time, we saw major advancements. But it wasn't until this time, age of the customer, when we're reevaluating products, that we see speech recognition applications that we know of today. And what applications am I talking about? For example, Google. I was like, okay, Google. I was hoping someone's phone would react to it. Yes, something that we all see. It might be pre-installed on our phones. There's Bixby for Android. Alexa. I have this same model, the Echo Dot, at home. You can do shopping, hear the news, just with voice commands. So, and to exemplify, to show you just how advanced speech recognition is, these are or two applications I thought were really interesting. One is called Shazam. It's popular in America, but you can just the app will listen to current music playing, and with a very short clip, it could be in the middle of a song, or it could be kind of there could be other noise in the background. It'll tell you exactly which remix or which cover or version of the song that you're currently playing is. A lot of times it'll give the lyrics of the songs and everything. Yes. And another application that has advanced speech recognition is Pocket Talk. I don't know if people know this, it's popular in Japan, and it will translate real time what you say. And you might think that this is also difficult to kind of incorporate into your own applications, but I will show you another demo. This time it doesn't involve money. And for example, if you say, spin. Spin. It recognized me saying spend. Spin. Jump. Yeah, that's the other one. Stop. Stop. Enunciation is very important. Okay, I'll try. Spin. Okay, well, afterwards, if you're interested, I can show you the demo more. But this is a problem that a lot of developers were facing, is that it's really hard to distinguish exactly what you're saying, especially if there's white noise, how clearly you speak. You might pick up someone else's voice. And of course, if you had really expensive equipment where you have headsets, mixed reality, then it's a little better. But I wanted to look at how easy it was to use these technologies with applications that are easily accessible to all of us. So I'll be showing you how I created these apps. Technologies, I used three main technologies. Unity, where I compiled everything. And through Unity, I incorporated Vuforia for augmented reality, AR, and IBM Watson for speech integration. A little bit about Unity. Unity is a popular engine often used to create games. There's a free version called Unity Personal. And actually in 2018, almost half of the games, the new mobile games that were released, were created in Unity. So that was very interesting. It's also cross-platform, meaning that if you create one game or application for an iPhone, you can easily use the same scene for Androids or laptop. And what Unity allows us to do is you can create a 2D game like this, just as easily as a 2D game like this. And the reason is because they have a lot of assets. They have a store, and you can kind of download presets, textures, materials, and easily manipulate them. I don't know, those of you in the front might be able to see this Unity Learn, but they also have a lot of tutorials, so they walk you step by step to how to create it. And they also allow you to create 3D scenes and applications. So Unity gives developers the power to control what they call 3D game objects. And in this really beautiful scene, the 3D object might look complicated, but it's just the same as what you saw me use, which was a sphere or a cube. And this is the Unity interface. So when you first open up your application, this is kind of the default scene. They have a project directory, so you can see all your files in the folder. And if you drag your scene to the top, you can access each component within that folder file. And on the right, there's an inspector view where you can control and manipulate different aspects of each component. So color, the shape, you can add scripts. I use C# scripts. And at the top, if you press play, you can run how the game might look. And while you're running the game, you can check and debug easily with the console on the bottom. So everything from kind of writing code to or adding scripts and like manipulating the actual objects and compiling and debugging and testing, you can do all within Unity, so it's very easy to use. And a little bit about Vuforia. This is what I use for AR. Vuforia is another popular engine. They also have a free version, and they're known for being easily integrated with other things like Unity. And they're known for like image recognition, object tracking, and plane detection. So all the advanced technology you would need to create augmented reality. And this is an image of a coin. All the yellow marks is what Vuforia is telling us where this image is best trackable. And as an example, the image that I chose, I fed this to Vuforia, and it analyzed it, and it returned to me all the points that had best tracking. So tracking was earlier when I turned the 1,000 yen around, the figures were able to stay in the proper orientation. And Vuforia will also give you a rating of how augmentable it is. 1,000 yen was highly augmentable, so I was like, great, I'll use it. I originally wanted to do it on my hand, so I took a picture of my hand and uploaded and tried to make different contrasts, but it had 0 or 1. So, fortunately, that's probably for further improvements of making maybe objects or planes more detectable. And then finally, you can just add 3D game objects onto where you want on your image, so it will appear in that location. So now you know how to create an AR app. And how to incorporate speech. IBM Watson is kind of like a supercomputer. It's a computer system that's able to think like a human. And Watson was actually named after the founder of IBM, Thomas J. Watson. And a lot of artificial intelligence, machine learning, natural language processing went in to create Watson. But why? Why did they want to advance Watson? And this was because they wanted him to participate in Jeopardy. So actually, in 2011, Watson won Jeopardy. For those of you who don't know what Jeopardy is, it's like a quiz show. And this is Watson in the middle. Watson won $1 million. So how can we use Watson? IBM allows us to use a lot of different services, Watson services, and they can involve tone analyzing, language processing, language translation, and what I decided to use was speech to text. So, that's kind of how. And you can give it, add different commands. I chose jump, spin, and stop. So if you want to try it later. But what's next? So up until now, we've seen different, two different parts of what makes an immersive experience kind of immersive. And this was extended reality and speech recognition. But I think what will happen from now and beyond, we've kind of seen these two develop parallelly. And currently, it's not as easy to put them together. But most likely what lies beyond and what will create our immersive experiences is putting these together and combining different advanced technologies so we can get immersive experiences. So hopefully you're just as, I guess now you're motivated to try maybe Unity, or you're excited about AR, VR, or speech recognition. And yes, I just want to leave you by saying, welcome to the age of experience. These are a few references. Yes, thank you.
Thank you, Ashley. That was awesome. I love augmented reality. Next up, we have Antonio Ironman Malakat talking about heart rate variability and how to measure it with wearable tech. So let's be back at 4 o'clock. Thank you. All right, next up is Antonio Malacat with measuring heart rate variability from wearable tech. Let's give it up for Antonio.
Okay. All right. Good afternoon, everyone. Thank you for coming to my talk. I will be talking about measuring heart rate variability from wearable tech. So before I begin, just a quick medical disclaimer. This talk is for educational and informational purposes only and may not be construed as medical advice. The information is not intended to replace medical advice offered by a physician. I am not a doctor, so just want to make that very clear. So a little bit about me. So my name's Antonio, and I'm the one on the top, in case you were wondering. This was in Komodo Island. I took the photo last year during the summer. So I was born in Manila, but I grew up in Tokyo. And I studied chemical engineering before coming to Code Chrysalis. And I ran track and field, and I played football in high school, and that actually relates to how I chose my topic of heart rate variability. Now you might be wondering, I don't see the connection, so let me walk you through it. So when I was an athlete, I would practice for maybe 2 hours, every day in order to get better for my sport. But the thing about with your sport, and if you practice, is that you have 2 hours of practice, but 22 hours where you're not training, and those 22 hours are pretty important. What you do in those 22 hours can affect how you perform the next day. So things like recovery, getting good sleep, eating well is important. And one way to track recovery is heart rate variability. So I came across that 6 years ago, but I ran into some roadblocks that stopped me from pursuing this. So first was I was limited by the expensive equipment you needed back then. You needed a dedicated machine that was a bit pricey for a high schooler, and there was some proprietary software that you needed to use in order to use the machine as well. So I kind of left it at that. But recently, there's been a lot of newer and portable hardwares that have been developed, and I know how to code, so I wanted to see if I could revisit this problem and attempt to do it on my own. So for those of you that are wondering, what is wearable tech? Because that is the hardware that has been developed that I'm referring to. So it is any device that you wear that can send or receive data. So how many of you have a wearable tech with you right now? Just a show of hands. A couple. So things like an Apple Watch, the Fitbit, Samsung smartwatches, they're very common. They're not the only ones, but they're one of the more popular ones in the market right now. And there are a lot of reasons why you'd use or have wearable tech. And one reason is just the sheer amount of health data you can get from it. A phone's great for getting how far you walk, but when you have an actual smartwatch on you, you can get so much more data. Heart rate, activity, things like that. And it allows you to log this data over time so that you can see your trends. Maybe you're a bit frustrated that you haven't been losing weight or being as active, but if you zoom out of maybe a week and look at it in terms of months, and you're seeing progress, that can motivate you to keep doing what you're doing. And it gives you accountability and information about your own health. So, what is heart rate variability? This is why you're here, right? So it's the variation between your heartbeats. Specifically, it's the beat-to-beat difference in time. So if you think of a metronome and you set a particular tempo and you time the time between each tempo, you're going to have a very consistent time. And because it's very consistent, the variation in that is going to be low. On the other hand, if you have a heart condition like arrhythmia, where you have irregular heartbeats, the beat-to-beat time in one instance is going to be different than in another. So why is heart rate variability important? So I want to ask you guys a question. What controls our heart rate? Any ideas? Okay, well, if you guessed brain or your nervous system, you're on the right track. It's pretty much modulated by our brain and central nervous system. But is it voluntary or automatic? I hope you guys say automatic. If it's voluntary, you need to talk to someone because they would probably discover something new. So, what does this mean though? What does it mean that our heart rate is controlled by our brain, but it's automatic? So it means that our heart rate is generally a response to our environment. So if you're exercising, if you're running for dear life, if you're giving a public talk, you're probably going to have a high heart rate. On the other hand, if you're sleeping, if you're watching Netflix, if you're just lounging about, you're probably going to have a low heart rate. So heart rate variability is a good proxy for measuring these involuntary processes that happen in our body. What do we mean by involuntary? So what we control is our skeletal muscles that help us move, talk, make facial expressions. But aside from that, there's a lot of things going under the hood in our body that we don't actually control. So things like the smooth muscles for your digestion, that's not voluntary control, or the cardiac muscles that cause your heart to beat, they're also not controlled by us. So heart rate variability can track how this autonomic or involuntary process is running. And these processes can be divided into two general responses, sympathetic and parasympathetic. So the sympathetic is your fight or flight response. It is purely survival. So you'd have an increase in heart rate, your blood flow increases, your breathing rate increases. You want to get as much blood into your muscles as possible so that you can do something, whether it's run or fight. But when this happens, your heart rate variability decreases because you want your heart to be as consistent and as mechanical as possible. On the other hand, the parasympathetic response is your rest and digest. So think about after eating a big meal or winding down before going to bed, you're going to have a pretty relaxed and decreased heart rate, and your variability increases because your heart isn't under any stress. It doesn't have to force blood to your body like if you were in a stressful situation. So we know that a higher heart rate variability would suggest that you're well rested or you're relaxed, and a low score would be more of a stressed or you're still recovering state. So how is heart rate variability measured? Does anyone know what this thing is or have seen it before? So it's called an electrocardiogram or an ECG, EKG machine. And what it does is it hooks up pads to your chest to measure the electrical output of your heart. So you'd see this in your doctor's office. And this machine can measure the electrical output with respect to time, or frequency, or other nonlinear methods. But time is the most common, and that's the one that I was using. So how can you obtain this ECG data? If you go to a doctor's office and get your checkup, you can get it there. But the problem is it's very inconvenient. Every time you want to get it, you have to go to the doctor's office. So there are some alternatives, such as a chest strap heart rate monitor. And it's good because it still measures the ECG readings from your heart because it's mounted on your chest. But if you're wearing this the whole day, it can get pretty cumbersome. So if you guys have been noticing the trend, there is wearable tech, such as smartwatches, that can do this for you. So it's pretty novel in that it can read these signals from your wrist instead of having to be mounted directly onto your chest. So let's look at how the Apple Watch does it. So it's integrated with the Health app, and the ECG data can be recorded with a Series 4 or later watch in supported countries. And you use the ECG app to take a 30-second reading, and depending on where you're wearing your watch, you use your other hand to hold the dial, and that creates a closed circuit, which allows the watch to read the electrical current from your heart. And this data is stored locally, so if you want to access it, you have to export it from your watch or phone. So here's a list of the countries that support this feature. Right now there's 32, and if you notice, there's no country that begins with J. So it's not supported in Japan yet. I'm not entirely sure when they'll decide to implement this feature, but I had to work around this situation because I have no access to ECG data from an Apple Watch. So luckily, there are publicly available data sets that are used for research purposes. Specifically, I used the MIT BIH arrhythmia dataset, or database, and it has 48 samples of 30-minute ECG readings that are sampled at 360 hertz, which means 360 samples in 1 second. So very long data sets, very high resolution, so it's great for analysis, but it's probably a bit overkill. So you're probably wondering what this ECG data would look like. It's going to be a long column of numbers. So the first column would be the time or sample number, which is the instance in which a current is recorded. And then you'd have the electrical signal strength in the second column. You might have the date or time of reading either in the header or the file name. And this file is generally stored in a comma-separated value, or CSV file. So the fun part is trying to obtain heart rate variability from ECG, or turning this into that. So how do we do that? Well, first thing is you need to set up the data to be in your device. So you need to acquire ECG data either from your wearable tech or a data set as in a CSV format. And you need to put this CSV file in the same directory as whichever coding environment you're working with. So let's say it's there, and we need to use a CSV parser, which is a program that can kind of go through the CSV file and take the values we want. So in this case, we just want the middle column, which has all our data in it. So to do that, we need to separate the entire file by commas and line breaks, and just get the electrical signal column we want. Once we have this data, we can put it into an array for easier usage so that we can plot it or do operations to it. So let's say we do that and we plot our ECG data, and this is what it would look like. So one of the things you'd notice are these really sharp peaks. They're called the R peaks. So there's 7 of them in this graph. And if you remember what heart rate variability was, it's trying to measure the time, the variation in time between heartbeats. So these coincide with our heartbeats. So the next thing we need to find is the time between beats. That's called the RR interval, or the time between each interval. So in this case, there are 6 interval times from 7 peaks. So if it's hard to follow, you have 5 fingers and 4 gaps between them. So let's say we are able to do that. We need to process the data, and that involves finding the mean or average and the standard deviation. It's a bit heavy on the math, so I came up with a couple analogies to make it easier to understand. So this is a bullseye or a dartboard, and the mean is where your data is clustered or centered on. So if I shoot a couple times, you can see that my mean is somewhere over there, right in between where the middle of those data points are. On the other hand, standard deviation is the spread of the data from that particular center. So if I try again with green, you'll notice that the mean is actually pretty similar, but the spread of the data is a lot wider. So this has a greater standard deviation than the red. And finally, these two concepts, mean and standard deviations, they don't necessarily have to be a real value, but what they represent is what's important. So for instance, if I try to shoot a bullseye and I'm off to the left, and I try to shoot again and I'm off to the right, my mean is actually the bullseye, but I didn't actually score it, so that doesn't count. So first thing is getting the average RR interval. So we need to get every instance of the RR interval, sum them together, and divide it by however many we have. So if we look at our previous example, we have 6 RR intervals, so we add all 6 and we divide by 6. Standard deviation is a bit trickier because there's more math involved, but it generally boils down to finding the difference between something. So the first one is the standard deviation of RR intervals, but if you look into the literature, you'll see it as SDNN, which just stands for normal peak. So if you turn the data to normal, it becomes N. But the idea is, within each RR interval, you're trying to subtract it from the average value we calculated earlier. There's another one, which is a bit of a mouthful, but it's the root mean square of successive differences. So this is the important part, successive difference. It just means that you're trying to find a difference of the interval with respect to the one coming after it. So it's just looking at a relative difference. So how do we find the RR intervals from our array? So this is it visualized, and it's actually pretty easy to see it when you look at it, but trying to find it from an array is tricky, and that's where different sorting algorithms and data processing comes in handy. So there's at least 7 different algorithms that medical professionals have developed to analyze ECG, so there's plenty of scripts out there to do it for you. And the other thing is we need to know the sample rate of our data. So right now, this only represents the distance in terms of indices from each data set, but we need to know how much time is in between it. So once we know the sampling rate, we can calculate that easily. Then this is just a simple iteration where you find a difference between each value. And once you have your R intervals, you can solve for the three equations. So let's take a look at that. It seems a bit abstract, but once you see it, I think it'll make a lot more sense. So we'll have two data sample sets that are 30 seconds long. So we have sample A and sample B. So what you'll notice relatively easily is that there's definitely less beats in sample A than sample B. But that's probably it that you can tell from just looking at it, which is why we do these math operations to give us numbers. So we can see that, yeah, sample B is definitely faster in terms of the average beat to beat difference. And the variations is actually greater in sample A. So there's more variation between each beat. So what does that mean? So given our current data set, all the results are in times of milliseconds because we're still looking at the difference in time. If we have the average R interval, we can actually calculate the instant pulse or beats per minute of the value. So in sample A, it comes out to 60 beats a minute, and in sample B, it's closer to 91 or 92. And then there are these two values, the successive differences and the standard deviation. These two values both measure variation, but which one is better? Because they're both valid values for heart rate variability. So standard deviation is good for a longer duration sample because you have a lot of data sets, the mean becomes more relevant. But the successive difference is better for shorter samples because you're only comparing a relative difference from each RR interval from one to another. So think of the bullseye. If you have a lot of data sets, the standard deviation is the way to go. And if you have very few, the successive differences is a better choice. So let's take a step back and understand why we went through all this effort. So we know that heart rate variability is a great proxy for monitoring our health and the autonomic nervous functions of our body. And it allows us to engage in something called biofeedback, which is changing our behavior based on something we're measuring. So if our heart rate variability is quite low right now, meaning we're a bit stressed, something we can do instantly is just take some deep breathing exercises to relax, and then on a longer time scale, maybe alter how we're behaving. So maybe increase our sleep, do some more exercise, things like that. And it allows us to quantify these intangible variables such as recovery. It's hard to say, oh, I'm kind of recovered today, or I'm very recovered today, but having a number makes it a lot easier. But heart rate variability is not perfect. So things like our sampling errors. So based on what device we use to measure the ECG, it might not be a reliable data point. Also, the consistency of our data. If we are very consistent in measuring it every morning or every afternoon at the same time with as much of the conditions similar as possible, then it's more useful. But if you're kind of taking it whenever, it's not as useful. Again, quality of data. So this ties in with which hardware you're using. And data validation. So let's say you have an ECG value or heart rate variability value from your watch, but it would be the same as if your watch was a couple of minutes off. The relative value will be meaningful, but in terms of an absolute value, it's not precise unless you validate it by going to a doctor's office to see that the numbers match. So in terms of wearable tech, they're very convenient. You can measure a lot of things. It gives you a lot of easy access to health metrics that you can use, and it gives you a good reference point for what is good health as a general guideline. But it is not a substitute for medical advice. So always go with your doctor at the end of the day. And there's also a lack of standardization and personalization with health tech. So let's say Apple has the SDNN as their way of calculating heart rate variability. Fitbit might choose a different method, and they're both valid values, but because there's no regulation about which is what you should use, it's hard to tell or to compare between different users. Finally, there's also outliers not being accounted for. So if you have a benign heart condition, this might not be useful for you, or if you have any other health condition that isn't really accounted for in what a standard health would be, these wearable techs are still not personalized to the extent that you could use it or benefit it as much as the average person. Another point is data privacy. So once you export the health data in your Apple Watch to your laptop, or you put it on the cloud, if there's a breach, it's gone. There's no authentication or extra layer of security for your health data. So it's one thing that people need to account for. And finally, more data does not mean better health. So at the end of the day, you can have as many health metrics telling you all about your health, but if you don't do anything about it, it's pretty much useless. So two things I want you guys to take away from this talk is that heart rate variability is a useful tool for your tracking your health, but it has its limitations as a metric and getting accurate readings. So thank you for listening. Here's a link to the GitHub repo.
Good job, Antonio.
Thank you.
Next up will be Miss Asami Kamiya, right? Talking about image recognition with JavaScript. Please be back here at 4:30. Thank you very much. right, people, let's learn about image recognition in JavaScript with Asami Kamiya. Yes, let's go.
Hi everyone. Today I'm going to talk to you about image recognition in JavaScript. Today's agenda is like this. First, let me introduce myself before I'll get into my topic. My name is Asami. I live in Aichi Prefecture, and I work for an IT company as a system engineer. And I'm responsible for creating web app using Java mainly. And I like eating, like this photo. So eating is a kind of stress relief for me. So now let's get into today's topic. First, I'll explain about what image recognition is. Image recognition is a kind of pattern recognition technologies which identifies features from images. I don't think this is enough information, so I'll explain it with some specific example. Image recognition is to let the computer figure out the object in the image and to let the computer recognize it. Human can guess the object's movement and places by just looking at images such as photographs, but computer cannot do it because computer doesn't have any experiences and memories like humans. So if you just give a computer an image of a cat like this, the computer will not recognize it as a cat. So in image recognition, computer needs a large amount of images from a database, and the computer automatically learns the characteristic of the object. And then the computer can understand the characteristic of the cat from image data. And if the computer is given a new image with the same characteristic of the cat, computer can figure out it is a cat. And image recognition has become a hot topic in recent years with the advent of deep learning. But it has existed for a long time, and it is surprisingly an old technology. So, in the oldest image recognition is a barcode reader from the 1940s. It may seem too simple to call it an image, but it's also an image recognition because it reads information from the pattern of the image. And in the 2000s, data could be processed at high speed with the development of computers. This change will make it possible to perform image recognition by machine learning using a large amount of image data. And image recognition technology will shift from manual and model construction to pattern recognition. Next, in 2012, deep learning appeared in an image recognition tournament called ILSVRC 2012. The model using deep learning hits the correct answer rate of about 85%. So today, image recognition AI has reached the stage used in industry. So next I'll explain the mechanism of image recognition. First, in order to perform image recognition, objects must be extracted from the image. So humans can judge an object visually from an image, but for a computer, an image is just a collection of information, like color or brightness, like these photos. So before image recognition, the computer needs to make the image easier to recognize. So for example, remove noise and distortion from images, and by enhancing the outline of the object and adjusting the brightness and color, and cut out the area of the object from the image. In order to recognize an object,
it is necessary to provide a large amount of image data and labels, and then train the object. This needs machine learning. The computer learns the characteristic of the image data for each label based on the combination of the image data and the label. As the learning progresses, the computer can figure out the characteristic of the object from the image data. For example, if it is a person, the computer obtains information such as 2 eyes and 1 mouth. So if you give an unknown image to the computer based on these learning results, the computer will be able to recognize the object from the unknown image and express what the object is. With the advent of deep learning, we have succeeded in recognizing images with unprecedented accuracy. So next, I'll explain the connection with deep learning. Deep learning is based on neural networks, which are systems that mimic the mechanism of human. By using neural networks in multiple layers, it is possible to learn features included in the data, step by step and deeper. By inputting a large amount of image in the multi-layer neural network, the computer model automatically learns the features included in the data at each layer. So this structure and the method of learning are unique to deep learning, which makes the model for deep learning extremely accurate. So sometimes it can exceed the accuracy of human recognition. The most commonly used deep neural network is a convolutional neural network. It's called CNN. The features of CNN are defined by dividing the neural network layer into 2 types of layers. One is convolutional layer, and the other is pooling layer. In the convolutional layer, several patterns of new image data are created by calculation by using various filters and feature amounts. In the pooling layer, reduces the resolution of an image to create abstract image data. By repeating, the data amount of the original image is reduced, while retaining the features, and it is possible to finally classify what the image is. So next, I introduce examples of solutions which use image recognition. The first is face recognition. Face recognition is a technology that extracts prominent features from face images. Face recognition can be used to identify search for similar face and group faces. And emotion recognition is also famous. It reads emotions from human facial expressions. It is also used for security, such as surveillance cameras. Next is character recognition. Character recognition is a technology that distinguishes handwritten characters on paper and printed characters. This allows us to extract text from images. This field has been studied for a long time. The Google Translate app has the ability to translate text in real time using the camera. And in the medical field, solutions linked to AI. To create AI for recognizing images and the type of cancer cells has been successfully discriminated. It is now possible to distinguish small image differences that cannot be distinguished by human eyes. So in the marketing field, image recognition combined with social media. In recent years, when social media has spread, people's actions are uploaded daily in the form of photos. So with a service that analyzes these huge images using AI technologies, you can support product development by understanding how people live and what changes are taking place in the world, and trends and characteristics that cannot be noticed by humans. as I explained, in this day, there are many technologies using image recognition. So next I describe the methods can be implemented in JavaScript. I explained about basic information of image recognition. So I think it's difficult to develop the image recognition by myself. So we need to define the images by calculating pixels and to let computers learn images. But if you want to develop it by using JavaScript, there are many libraries and useful APIs. So to use them, we can try image recognition easily. So I'll introduce some libraries and APIs. First is introduction of the library. CLM Tracker is a JavaScript library for fitting facial models to faces in videos or images. CLM Tracker tracks the face and outputs the coordinate positions of the face models as an array. This library's good point is good accuracy, but point is we can recognize only one person. Next is Pico.js. This is a face detection library in only 200 lines of JavaScript. It can provide a smaller and computationally more efficient alternative. This library's good point is it can recognize multiple faces, and bad point is not good accuracy. Next is FaceAPI.js. It has several functions like face detection models, 68-point face landmark detection models, face recognition models, face expression recognition models. So we can use several functions. This library's good point is good accuracy and several functions. But bad point is this library's data size is too big. So next I'll explain about APIs. Clarify and IBM Watson. They are similar. So this API will return keywords that are highly relevant to photos, and you can build a web application which automatically categorizes photos and searches for desired photos from keywords. So I introduced some APIs and libraries to implement an image recognition system in JavaScript. So actually I created a small demo. I chose Face API to create image recognition demo because I can use recognition of facial expression and it can check the kinds of face. I tried to create small face recognition and facial emotion check, and to check the difference between human faces. I used those technologies for my demo. My demo can do face tracking and also check facial expression and capture a photo and check the difference between human faces. By using FaceAPI.js, it has face tracking system and face recognition. And Vue.js is for the app, display, and using camera, like line 7. And Canvas.js is for drawing face tracking, like line 10. And Express is for building server for my app. And in order to check the difference between human faces, I need to prepare some photos. It means a small machine learning. So I prepared the directory in my demo to place the images I want to check. So now I'll show you the small demo. This is a face recognition demo I created. It has web browser camera created by Vue.js. And if I push this button, the face tracking is started. And it has face detection with points and this area is for facial emotion. So to use this facial emotion, we can display some emotion animation like this. and we can check the different human faces. So I prepared some face to I want to compare. It's my face. So this demo has known my face. It's already learned. So now I'll try to compare the difference between my face and someone's face. So does anyone want to take a photo? Yes, please come here. Thank you. Please look at this. Here. And 3, 2, 1. Cheese. Thank you. So now I'll check. Yes, it's me. So this app can recognize my face. Thank you so much. Now I got my slides. So in my demo, I use JavaScript, but if you can use Python, you can create machine learning more effective. So Python and OpenCV suits the image recognition. Python is a programming language that has been gaining popularity in these days. And it is widely used in the AI field, so it is expected to increase further in the future. And OpenCV already has an image recognition program that detects objects in images. So it is better to add the function that you want to implement as programs based on them. By combining Python and OpenCV, we will be able to use various types of image recognition. So finally, I will explain the future about image recognition. Image recognition technology has evolved significantly with the introduction of AI. Object recognition AI has the same correct answer rate as humans, and it is already being put to practical use in various industries. So it is expected that the use of image recognition technology will further expand with the development of IoT technology and the use of big data. And we expect further technical advances such as improving the accuracy of face recognition and establishing emotion recognition technology. And with the development of technology like combination audio data and AI technology, so we also expect further excitement. That is all. If you are interested in my topic, please visit my GitHub account. Thank you for listening.
Thank you, Asami. AI is super cool and super scary at the same time. Next up, we have our final speaker, who is Nemanja, and he will be talking about TypeScript. It's a technology that I personally like a lot. So let's be back here at 5. Thank you. for our final talk of the day, we have Mr. Nemanja Milenkovic talking about why do we need TypeScript. Please give a hand to Nemanja.
Thank you, and thank you, Vic, for actually suggesting this topic. Thank you, Dustin, for helping me doing this whole talk. And now, yeah, well, let's start. Let's start with me. My name is Nemanja Milenkovic. I originally come from Serbia, which is a small country in about Central Europe. Now I live in Tokyo, but I do spend most of my time here at Code Chrysalis. And here I usually use JavaScript, which actually is the reason why I chose to continue and talk, learn, and know more about TypeScript itself. Now, what is TypeScript? TypeScript, as you can see on the official website, is a superset of JavaScript, works everywhere. That basically means it's JavaScript with additional features, and that's actually important. Another thing that's important is it is JavaScript. No, it's a valid TypeScript. So JavaScript is a valid TypeScript. What does that mean? Whatever you write in JavaScript will work if you rename it to TypeScript or you do it in TypeScript as well. Now, let's dive a little bit into all that. The first main additional feature would be a support for pretty much all or most of more popular IDEs, which will allow you to use things that you cannot use with JavaScript, like IntelliSense, or more advanced syntax checking and everything related. Another and the major point is TypeScript is strongly typed, unlike JavaScript. So in JavaScript, if you have a value, it can be anything. You don't need to say what it is. It can be a string, it can be a number, it can be an array. You can change that later. And while that kind of works and kind of helps us a little bit because it gives and provides some flexibility, ultimately, especially if you have a little bit larger code base, it will lead to bugs, and probably many bugs that you probably wouldn't like. And now let's see those types and how to use them. Now here the first example would be a boolean, so true or false. Only thing we need to do there is add colon boolean, name of the type, and we are pretty much finished with that. If we want to do that with string, we do the same thing, and now we have, and we know we have a variable, that is a string, and we know it's a string, it will always be a string, and it of course holds a string. We can do that with arrays. We can say this array can hold only numbers, for example. We can do that with tuples, that's a new type for TypeScript, for JavaScript, and there we can say which types our array can take. We can use enums that are pretty neat if we want to keep our code clean and organized. We can use any, probably we shouldn't use it all the time or ever, but there is an option to use a type any that can be anything you like. We can, for example, again, use void if our function like this one, because it's a console log, doesn't return anything or shouldn't. We can deal with objects, and we can of course use interfaces, which are actually really useful. Natively, JavaScript does not support them. Most of you that are coming from some different languages would probably recognize interface too. Now, more types means less bugs, and that's the whole point of TypeScript. To prove or to investigate that point, I prepared a small quiz. I like to call JavaScript Shuffle, and I really think that's a cool name. Now, let's see, let's try to guess what the next thing will evaluate to, what the next line will evaluate to. So if we try to run this, what do you think we will get? We have number 42 plus an empty array. So would anyone like to try? I'll start this off. So we got string 42. which is okay. Maybe not too unusual, but probably not something we expected. Let's try with another one. We have an empty string plus an empty object. Would anyone like to try? What would this evaluate to? Anyone? Please.
True.
True! It's not true, it's false. I mean, it's an empty object. And yeah, doesn't make much sense, but that's what it is. Now we have the same thing, actually. So we have object plus an empty array. Now we just switched places. We have an empty object plus an empty array. That should evaluate to the same thing, like an empty object, right? No, it evaluates to 0. Doesn't make any sense, but it does. We have an empty array plus an empty array. What does that evaluate to? Anyone?
Empty array. Empty array.
It's empty, but it's not an array. It's not an array. So it's really difficult to predict what will JavaScript do next. Empty object? 0? Not a number. And JavaScript is actually right. It is definitely not a number. It's not something we expected to happen, but it's not a number. So at least we got it to some point. Let's evaluate this. 4 is greater than 5. 5 is greater than 6. Obviously, this should not be true, so this should be false. And yes, it's false. JavaScript knew this well. I'm quite happy with JavaScript at this moment. So maybe we don't need TypeScript. But if we do this, which should be pretty much the same thing, just switch. 6 is greater than 5, that is true, right? 5 is greater than 4, that is true, right? No, it's false. For JavaScript, it's false, I don't know why. Now, let's try to do a simple math. This is not too difficult. Have 0.4, 0.2, that equals 0.6, true or false? True! No, it's false. Why is that false? 0.4 plus 0.2 actually evaluates to 0.6, but not quite, so there is a little bit more than that. Let's do one more, the last one. A bit more complicated, a bit more complex. Now we do have array, takes 10, we call a method join, we pass JavaScript as a string, -1, and add Batman as a string to it. Would anyone like to try? I can help you, this will run. This is a valid JavaScript code, this will run, this works. Hence TypeScript. So, how to start TypeScript? We can add TypeScript to our global environment using yarn global add TypeScript. If we are using npm, we can do the same thing by using npm-e or I TypeScript-g. Now, to initialize our first project, we do that with tsc-init. TSC stands for TypeScript compiler. And that's pretty much all you need to start. It's actually really easy, really simple. If you just want to test it out, you want to see how it looks, how it works, it's probably better to start with the TypeScript playground, which you can find on official TypeScript website. And I will just quickly go through it, introduce it at least briefly, so you know what it is. On the right, or well, left, you have JavaScript code. On your left, you have TypeScript code. You can change that if you go to config part. And there you can play with a couple of other options. One that I personally recommend is you can check how your code would look in different ECMAScript versions. TypeScript actually compiles all the way down to ECMAScript 3. Which means that, and ECMAScript are basically sets of standards for JavaScript. So that means that you can see how your code that you typed or wrote today would have to look like 10 years ago. So it could be ran on majority of browsers. You can check examples. That's the part where you can do this. For example, if you check async await, That's a lot of fun, I guarantee. But let's not go into that. Let's go into a simple example like hello world. And let's start with JavaScript. So we have our variable greeting holds a string, which is hello. We have a function. Function's name is hello. Takes greeting, returns a string where greeting is inserted and the string ends with world. So it's relatively, or let's say very simple. We have our console log, so we want to see the result. Console log is logging hello function that takes greeting. We can expect the result from here, I'm pretty sure. We take hello world as we expected. Now, if we change something, and let's say we want to change greeting to false, that will work. And JavaScript will not complain, and we get false world. Now, that's probably not a world we want to live in, and that's probably not something we wanted to happen. So let's just remove false. It still works. JavaScript allows this, and we get undefined world, which is probably even worse than false world. So let's move to TypeScript. Let's open up the same file in hello world.ts, and that works. So this is JavaScript in TypeScript file. It works. Why does it work? Because JavaScript is a valid TypeScript, as we said. So everything will work. You just add as you like more to it. So the first thing we see, we got an error, which is actually a good thing. And TypeScript is telling us, okay, you're not passing anything into this function. We are expecting one argument. Please do that. Okay, we do that. And now we just, to make sure, we say this argument on line 3 should be a string. We pass, or we try to pass false, we get another error. And it says, okay, this is not a string, you cannot do that. So, we change that. We also say greeting is a string now. And we, on line 3, say that this function needs to return a string too. Now, with just a couple of changes, we are pretty sure that this function in this very simple example will pretty much always work the way we intended. And it's also very easy to read. Easier than it would be to read JavaScript, because you know what each element of that code is. And you follow along. Now, when do we do TypeScript? Probably not necessary for something as simple as hello world. But the thing is, we never really know where our code will go and how big will it become. And how difficult will it be for some future us or future developers or developers in the future to maintain that code and maybe debug as well. We know some examples of some side projects that started as really small projects and ended up being pretty much industry leaders. Twitter started as a side project. No one pretty much believed in Twitter as a project when the guys from the company started it. We have Slack, also started as a side project, basically started as an internal communication tool for the company that built it. And we had Airbnb, Rafael mentioned before, also side project, very small project. And actually, from these 3 companies, Slack is on TypeScript, and Airbnb just recently ported their front end to TypeScript. And after doing so, they did analysis that said, since they did that, they basically prevented 36% of bugs, or they would be able to prevent 36% of bugs. So it's kind of huge, especially for a company with the quality code base as you would expect from Airbnb. Now, let's try to check and do another example. So this will be a little bit more complicated, a little bit longer, but I'll try to guide you through it. And even if you cannot follow everything, I'm pretty sure you will be able to appreciate TypeScript in a way that it will tell you what is what should do what, and what should take what. Now, to our left we have JavaScript code, and to the right same thing, just in TypeScript. And we start with a class item. Now that class has a constructor which takes tot. Tot probably is total, or I'm not sure. Because this should be an example of a code that you can actually see very often. And very often you cannot really tell what whoever wrote it, and that can easily be you at just 5 days before. You cannot always tell what the person who created that piece of code really intended to do. And here it's kind of difficult to say, because we do have size, but it's a string, it's large, okay. We have quantity, it's tot, which probably stands for total, okay. We move that to TypeScript, and yes, immediately we do have an error, and it says property size, and it would say also for the quantity, it does not exist on the type item. So now we change that, and actually that can be even changed with a quick fix. So if you just do quick fix, TypeScript will try to help you. You probably shouldn't do that all the time or often. But even with a quick fix, we get something that we can read, and we can kind of be certain what it does in a way, or at least what it takes. Now, if we want to create an instance of the class item, we do that in JavaScript. The JavaScript doesn't complain all this time. So everything we do in JavaScript actually would work, or at least would not break while we are writing it. It would break, but during runtime, and that's kind of the only time when you don't want your code to break. Now, TypeScript takes this, but immediately complains, says, okay, number 1, or string 1, is not assignable to the parameter of type number. So string cannot be a number. It takes that, sees that. You didn't see that, I didn't see that, but we did change that into a number, so it doesn't complain anymore on line 7. And now let's add some more. Let's see, we have a function, wait, and it takes an item. We don't know what item is, and in the body of that function we have math.for item.size times item.quantity. So we guess this calculates weight. We do that and move that to TypeScript. What do we get? Again, we get a warning. It says item has any type, but a better type may be inferred from the usage. So it tells us, okay, maybe you should give a type to this parameter. And we do. We know that we want to put an item there. So we say this item will be of a class item, of the type item. Now, immediately it warns us again. It says, okay, but now since you're providing this, you need to have a number there. It cannot be what previously, if you remember, on, let's see, line 4 was a string. Now we changed that to a number, and now we do not have a string that said large, we have number 2. And we move on, everything works well. Okay, we add another function, check capacity. So without going into too much details, we move that to TypeScript. Now we know already we need to do a couple of things, or we should do a couple of things. So on line 11 we added a type for our weight. On line 12, type for capacity. On line 12 as well, we also added a return type to this function. And now we get an error immediately. Type true is not assignable to type number. We follow that. We change that to -1, let's say. Okay, it works. We try to console log the result and call the function check capacity, which takes weight and the number. We do that in TypeScript, it doesn't work. Now, the very important error, and something that I guess at least some of you missed, is, did you mean to call this expression? So if we go back here, we see, among other things, that this line 9 was never returned. So this function actually didn't return anything, which means it would not work. Whatever we wanted it to do, it would not work, not in this way. But when we add return, this works. And that's it. We got a code that works. And we resolved all of the bugs before runtime, before the production, before we pass that to the user or another programmer or anyone else. And tomorrow when we need to refactor this code, we need to go back to this code or reuse this code, we know this will work all the time, everywhere, the way we wanted it to work, and we know that we will be able to read it better, even if we did not comment a lot or at all. Now, where do we TypeScript from here? So, what can we expect in the future? First of all, majority of front-end frameworks already support TypeScript. Angular, for example, is written in TypeScript. React supports TypeScript heavily using TSX components. Vue is actually announced to be ported to TypeScript from the version 3. And if you check Google Trends for TypeScript, you will see it does quite well. Also, according to the 2019 survey of Stack Overflow, TypeScript is among the most loved technologies developer care about. Now, let's do one more JavaScript shuffle, and this is the last one. Now, let's see. We got this. And I promise, and I will help you, this is code. This is a valid code. This is valid JavaScript code. There's nothing in this whole code except for empty arrays, parentheses, and plus signs, and maybe exclamation marks, I'm not sure. But that's it, that's all. Now let's try to run this. And if we open up our developer console, I had this copied beforehand. You can see the code again. We can try to run this code. And I'll try to zoom in a little bit, just in case. And if we run this code, this actually runs. And because it runs, and it really shouldn't run, I really think that is exactly the reason why we need and why we use TypeScript. Thank you very much.
So that marks the end of MiniConf. Thank you so much for coming today. I'd like to invite everyone to Demo Day, and that's going to happen on March 26th. And I see some nervous looks from the engineers here. That's where our amazing engineers will present their final projects. So please consider being here. That's going to be a really, really exciting day. Again, let's give a hand to the engineers. Yay! We will be open until 6 today, so feel free to network and mingle. Thank you all for coming.